Compound interest usually is in financial maths. However, this question is very interesting because it brings in a new idea that whether it's compound interest is compound increase actually. So let's see. In 3 consecutive years, the amount of firewood the company produces relatively to the previous year increasing by 6, 8, and 17%. So what that means? 3 consecutive years. So we have first year, and that increase is 6%. We have second year, and that increase is 8%. And then we have third year, and that increase is 17%. Okay. The total increase over this time, so over 3 years, is equivalent, meaning equal to what? An increase of R each year. So there is a specific increase each year compounded annually. So once we see that word compounded, we think about the formula for compound interest. So we have to work out the value of R, give your answer correct to 1 decimal place. So when we see compounded, we go to our table and we look at the formula, which is our financial maths. There it is, our first formula for compound interest. And it doesn't matter that in this case, that interest is actually compound increase. So let's take our formula, because we're going to use this idea here. So let's have a think how we will do the calculation. So whatever I had in previous year, before the first year, so there was a number there, and that was multiplied. If there is increase of 6%, that means it's multiplied by 1.06, isn't it? Because we still have 100% and additional 6. So that P means previous year. Now, what happened the next year? We take the year before, and that is multiplied now. We have 100%, but then 8% on top of that. So 1.08. And again, for the next one, we take that. So that's our previous year. And that now is multiplied by 100% and 17, because I still have what I had before. That's why 100%. Okay, so here my F, that is after 3 years. So after 3 years, that's the future value. And then that is at the beginning. And I, that's my interest rate, and the time we are talking about, that's 3 years, isn't it? So that's what I'm saying. Very interesting take on this formula, where normally we are dealing with money, but here it's about increase. Okay, so let's see how we're going to do that. So after 3 years, how much do I have? That's what I have, isn't it? After 3 years. So I have, oops, what happened here? I have 1.17 multiplied by 1.08 multiplied by 1.06 multiplied by P, because that's what was at the beginning. And then on the other side, I have my P, 1 plus, and in this case is R, because that's what I'm looking for, and the time is 3. Now, I'm looking for R. Here I have multiplication, so that means I don't need P. I can divide both sides by P, so P is gone. Therefore, I just have the numbers and 1 letter that is left. So where am I going with my calculation? I want to have letter equal a number. So that is taken to the power of 3. How do I get rid of that power of 3? We take what? A cubic root of the other side. And all these numbers. I wouldn't actually do a partial calculation here because that's a lot of decimal multiplication, so we don't want to cut it off. And then the last thing to do is that one have to go to the other side, therefore change the sign. So that way we have moved all our numbers to the other side. And now, oops, 0.6, and now we are left with R. So we put that in our calculator, we press equal, and we get 10.2. That is the value of R here. Now, just to restate that, because maybe I didn't make that clear, we are getting a decimal, but our answer have to be in percentage. So therefore, 10.2% to one decimal place. That's the value of R because it is expressed as R percentage each year.